40 years of gasoline price data that varies by state. And we're going to combine this with census and NHTS data to look at different driving outcomes. So we're going to examine both extensive and intensive margin adjustment. And we're also going to look at the different effect of price levels, variation in price levels, and in price shocks. And we'll talk a little bit about vehicle choice, although our data for this isn't quite as good. Because you might be concerned that there's a lot of correlation within cohorts, and it'll be hard to kind of tease apart cohort differences across cohorts from things within cohorts. We're going to try to a bunch of things to try to address that. I think the thing that we do that is most convincing is to inject more variation in when people's formative windows are by using variation across states in minimum driving ages. So some people start driving at the age of 15, some people start driving at the age of 16, some people start driving at the age of 17. And I mean, for a long time, I think in South Dakota, it was 14. So there's some variation in this formative window that we can exploit. One of the nicest things that we can do in this setting is to compare gas price shocks at different ages and see which shocks, basically in a horse race, which shocks are most persistent. And we can, there we go. I see in the chat that in Wyoming and Montana, it was quite young. So that's great. Driving ages are quite young. And so by doing these comparisons, we can kind of focus in on when this formative window is. And then we're also going to go and borrow a little bit some of the tools in behavioral finance to look at these cumulative exposure models and kind of compare and contrast our results. And then we'll try to do some interpretation of this effect that we see. What are the mediating effects? You know, early life gas prices have macroeconomic or these shocks that happen when people are 16, 17, 18 could have be correlated with macroeconomic conditions, which could have their own kind of effects on outcomes later in life. And then we'll talk about kind of how we interpret our results. So just to give you a preview of our findings, we find that formative experiences during a narrow window, which we define roughly as between 15 and 17 or 18, shape later life behavior. Doubling of gas prices during these first 3 years of driving age, if gas prices double, if you experience this gas price shock, you are 0.4 percentage points less likely to drive to work as an adult. So that's kind of commuting behavior, conditional on work. And conditional on driving, you drive 7% fewer vehicle miles on average. And you're also somewhat less likely to drive an SUV. We find that price changes are much more important than price levels, which kind of surprised us. So it seems to be something about experiencing a price shock rather than experiencing just high or low gas prices. We find that price changes outside of this narrow window between 15 and 17 or 18 don't have a significant effect on later life behavior. And to kind of quantify these effects, a gas price shock at age 15 matters 25 times more, is 25 times as important as a gas shock last year. And so when we talk about this cumulative exposure model, you'll kind of see what this looks like. What this gradient of exposure impacts looks like. We also find that these non-behavioral mechanisms or mediators don't explain the differences. So this doesn't seem to be differential skill acquisition or differential early life employment to the best that we can measure that. And it will contrast with standard behavioral findings and theories. So it's inconsistent with our findings are inconsistent with general notions of mental plasticity or in impressionable years, that teens are just kind of really kind of loosey-goosey in what they want and are kind of impressionable to whatever environmental factors there are that they encounter. This seems to be a little bit more precise and narrow than that kind of general psychological theory. Yeah, so especially in an environmental crowd, I just want to mention that there's kind of a big literature on a variety of aspects of vehicle choice. I think a couple of the papers that we want to link to are recent papers by Knittel and co-authors. There are a couple of teams that have tried to look at whether driving patterns are changing. And basically the kind of question of, are millennials different? And this line of research typically finds that once you control for differences in wealth, income, and like delayed family formation, people aren't that different. You know, the millennial generation has just kind of delayed its quote unquote growing up. But, and so this suggests that really once people reach adulthood, which maybe adulthood is shifting later, their driving behavior isn't really changing much in the US. We're also going to talk a little bit about links to a variety of other literatures. There's this kind of literature on how on how experiences accumulate to shape later life behavior in a variety of contexts. And we also link to this kind of cool literature on path-dependent effects of transportation. Most of that literature has focused on path-dependent effects of transportation supply, of infrastructure. There are a couple of cool papers out there about path-dependent effects of transportation demand. I really like this paper by the Anderson et al. Team that kind of shows intergenerational transfer of brand preferences for automobiles. You know, if your grandfather was a Ford man, your father was a Ford man, you're more likely to buy a Ford. So there's kind of some interesting literature out there, but we view our kind of our contribution as a little bit distinct from what's out there so far. So a roadmap, I'm going to talk a little bit about data, just to kind of set up where we go, because we're going to use a few data sets and cycle through kind of a common set of econometric exercises. The first thing that we're going to do though is just after we talk about data is look at patterns that are visible in the raw data. And that's kind of where the project started, is looking at raw data, trying to see, you know, what does driving behavior look like across several different cuts of the data. And you'll see something pops up about the 1970s. Then we'll look at these kind of a little bit more of a serious interrogation of the data, looking for the long run effects of gasoline price movements. And then we'll talk about how we can define this narrow formative window and what cumulative experience looks like, and then we'll interpret these results. So the data, in some regards, this is kind of, we're doing something non-standard with relatively standard data. We go to IPUMS to get the census data that, you know, anyone can download and work with. And we're going to be focusing in on the Journey to Work module, which basically since 1980 has asked people a variety of questions about how they get to work, where their work is, how long the trip takes, stuff like that. And so we'll be pooling all this data from basically 1980 till the 2017 ACS. A lot of our questions are going to be about commuting, which does limit our sample to workers, because they don't ask about transportation behavior for non-workers. But they do ask everybody whether or not there's a car in the household. So that'll be a margin that we can look at. And what's nice, of course, about the census data is that we have rich demographics, so we can do a fair amount to control for things that we think might be first order threats. I'm going to usually limit the sample to people who are not on a farm, because people who are on farms have different commuting behavior, to people who are native born, because I want to know what their exposure to gas prices were, or at least be able to guess, and who are prime age at the time of the survey, so people who are age 25 to 54. And this is just so that we don't get kind of weird cohort-specific differences at the kind of fringes of people's working lives. If you know, people who experience particularly adverse working conditions early in life might have different retirement patterns and therefore show up kind of as a selected sample later in the data. We're also going to lean on the NHTS quite a bit, or its differently named predecessors. We're going to pool these 5 waves of the NHTS together. And this is also a pretty standard data set. We got the confidential version so that we can a little bit more precisely know people's location. And what's nice is from here we get per vehicle and per person vehicle miles traveled annually. And we also know a little bit about what sort of vehicle people are driving. The kind of key component that is both helping us and limits us is knowing state by year variation in gasoline prices. And so we're indebted to Eric Mulligu, who shared this data with us, and we updated it a bit, but we get these kind of post-tax average prices within a state year cell from 1966, excluding Alaska and Hawaii. And the final kind of big piece that we're going to bring in are these driving license regulations. And so this is the part of the project that we did data collection on, which is going back into these old highway statistics reports from the Federal Highway Administration and trying to, from kind of a piecemeal record, and figure out what the history of driving license regulations were. I'll talk about that a little bit more later when it becomes relevant. So before I kind of, any big picture questions before I kind of dive into looking at some pictures? Cool. So yeah, the picture that I'm going to put up here in a minute will be kind of where this project started. First, a little bit of background on the 1970s. You probably know this, just in case not. There were kind of these two periods of rapid gas price increases in the 1970s. There's some debate in the macroeconomic literature if this was supply or demand driven, but there was a lot of kind of global uncertainty in the oil supply at that time. Regardless of the cause, this manifested in high gas prices in the United States in the 1970s, and these were relatively unexpected. And so this is basically the monthly real and nominal price of gasoline from 1965 to 1990, and you can kind of see delimited by these red lines, these periods of rapid increase. And so what we're going to do is we're going to look at people who experienced these gas price increases, and we're going to look at them in the year 2000 and see if they're different than cohorts just before or after them. So to just kind of clarify the timing I have in mind, maybe this is a little bit too basic, but you know, people are born, that's exogenous. They turn 15 or 16 and they start to learn to drive. Some will start to learn to drive during an energy crisis, during a period of rapid gas price increase, others won't. And then we're going to observe everybody uniquely everybody at the same time in the year 2000, when they're all going to be roughly in the same state of life, their mid-30s. But of course, there are going to be year-to-year variations, and we'll try to deal with that in a little bit.
Hey, Chris.
Yeah.
Is there any evidence that these types of shocks, going back to your figure, is there any evidence that these types of shocks would affect when people learn to drive?
I'll talk about that a bit later on. To the best that we can tell, and this is a bit hard to answer, there weren't effects on people learning to drive, and other types of frictions that slow down people learning how to drive don't seem to affect their ultimate driving behavior or their later life driving behavior. So, but that's a great question, and we're worried about it, so I'll go through that later. Yeah, so this is kind of our key picture that got us started here. So what this is, right, is in the year 2000, did you drive to work or not? And we've separated people by the year they turned 15. So, right, the people, maybe this is a little bit odd in that the people on the right are younger in the year 2000 when we see them, and the people on the left are a bit older. So you can equivalently subtract 15 from all these numbers and plot this by birth year. And you know, what's interesting is there seems to be something kind of different about this cohort that's just before 1975 and this cohort that's just before 1980. So there's a little bit of fuzziness in measuring when exactly, what year people were born in the census because of how the questions about age are asked. So we've kind of tried to do what we can with that. But this is essentially the raw data, and you see that, yeah, there's just something that seems kind of different about these cohorts. You'll also notice, of course, that there's a substantial slope to the right. That is life cycle effect. So these are people who are, you know, if you're 15 in 1990, in 2000, you're 25. People are still not kind of fully engaged in the workforce and have different driving behavior than kind of, than we see in the mid 30s and 40s when people's, I guess, lifestyle decisions are more set.
Chris, a question.
Yeah.
There seemed to be a pretty big drop in prices in like about 1986. Did you look at that, or is that too recent to do? Or
so, you know, we will do that in this sort of kind of initial just graphical exploration of the data and outcomes. We're not going to think about 1986, but when we move to kind of the full econometric exploration, we'll be using both positive and negative gas price shocks to as identifying variation. And you'll see that, I mean, so that will be in there. I mean, just kind of looking at this, so the period of rapid gas price increase was kind of in here. And so maybe this just before 1987 cohort is a little bit different in kind of the opposite direction in the way that we would think. So yeah, we're going to basically assume that the effects are symmetric throughout this talk, but you know, perhaps they aren't. Here's another very related variable. This is, did you take transit to work? So the sum of people who drive and take transit doesn't quite equal 1. There is a little bit of other margin for adjustment, but you know, this is kind of the reciprocal of what we just saw. And you see, you know, a similar sort of difference. And right, this and the last picture were both conditional on working or conditional on commuting. So now we'll look at a slightly different series, which is there a car in your household? And so, you know, households are composed of multiple members. That may confuse this picture a little bit. We've sorted people based on their age, and it's just, is there a car in your household? Do you have access to a car? And again, you kind of see something that's a little bit different about these cohorts. This series is also a little bit smoother, which is nice. But you also see this kind of life cycle trend pretty obvious. So we don't do anything too serious with this, but just kind of to get a back of the envelope guesstimate for the size of the magnitudes that we were seeing. If we wanted to attribute that to the gas price shocks, we would see basically these are kind of event study estimates in the range of -0.2 to -0.5 percentage points. And both of these gas price increases were, you know, in the neighborhood of 40 to 80% increases. So this is going to roughly accord with what we're going to find in the kind of full econometric specification that we'll play with later. To estimate this, we estimate these back of the envelope numbers using a regression discontinuity and time type estimator. And so we check observables and don't really see any other discontinuities or differences. And these results are pretty robust to the bandwidth choice and choice of functional form of the running variable. The results are also pretty intuitive in that, you know, you see a lot of substitution towards mass transit. You know, if you're cynical, maybe that's just an identity. Things have to sum to 1. But it's nice that it kind of goes in the direction that we would think it does. And I think even more telling is that the heterogeneity works in the way that we think it should work, in that our effects are stronger for people who have better access to substitutes of driving. So these are people who live in the urban core, and for people who are more income sensitive, so people who are, you know, contemporaneously at the lower income of decile. Now, there is going to be a little bit of a challenge whenever we're talking about contemporaneous demographics as controls in this setting, which is that the things that we see in the year 2000 or in later life are determined after your age 18 experiences or age 15 experiences, and so could be quote unquote bad controls. So we'll talk about that a little bit.
So Chris, you have a question?
Yeah.
Chris, it's Chris. I was wondering if you knew anything about the quality of the public transit where the people in these groups are moving to. So any sort of like, it seems like if you move to places where you can ride more easily, then that's an indication that you're kind of doing it intentionally, or yeah, that's all I was wondering.
Yeah, so this is why we report these heterogeneity results for this kind of, for the 2000 data in particular, is that it's a consistent definition of what the urban core is. We haven't, but could match people to the MSA that they're in. And then if we know the MSA that you're in and whether you're in the urban core, we can perhaps kind of, we can get at that idea a little bit. But we haven't done any matching specifically on like quality of transit. Yeah, any other questions before I kind of move into the, I guess what'll be the meat of the talk? Okay. So, you know, this was kind of a nifty little picture that I showed you, and I think is suggestive, but, you know, there were some, basically the lived experience of these 1970s era shocks might be very different than than more recent gas price shocks. You know, notably those shocks were accompanied with recessions. and were kind of unexpected. So we would like to establish that this isn't just a particular thing about the 1970s shocks, and see whether or not it's a more generalizable phenomenon. You know, another interesting thing that, because I went to UCSB and was a student of people who wrote these papers, there were also really big time costs of the 1970s oil crises in turn for drivers. So you had to queue up at gasoline stations, and it took forever to actually get gas, or so I hear. So what are we going to do in terms of generalization? So we're going to match prime age people's driving behavior to their state by year teen gas prices. And so for a lot of the data set, what we're going to do is further restrict the data to people for whom we know their state of birth and they currently reside in their state of birth, so that we feel better about the quality of our match in terms of, you know, assigning a particular gas price, vector of gas prices to your past experience. But we, you know, basically we try to do all the permutations of different ways of doing this matching that we can, and our results are going to be pretty robust to that. What's nice about this data series is that we can, you know, exploit some interstate price variation. So some of that is due to gasoline taxes. Some of that is due to gasoline distribution systems. But this is kind of a neat feature because so much of gasoline price variation is temporal. Having a bit of cross-sectional variation as well will I think, aid us in identification. And so just to kind of show you what the gas price series looks like, I put this picture up here. And so this is basically, this is an interquartile plot for every year across states. So we see the maximum and minimum state-specific real gas prices, and we see the interquartile range in the middle. So, you know, there's a fair amount of movement as time goes on, but gas prices are an AR1 process, and so you also see that kind of reflected here. We'll wind up doing a couple of different ways of measuring this treatment. We're going to have just gasoline price. We'll also look at gasoline price shocks, which we construct in this way, which are basically trying to get a sense of the percentage change in gasoline prices over a given period of time, over a given window, which is the difference between J and K. And so to give you a picture of what that kind of delta measure looks like, here is the transform picture of the prior series with a 2-year time difference. So this first line here is at 1968, and it's the difference from 1966 to 1968 in gas prices, with the same sort of interquartile measure here. And so because gas prices are kind of like an AR1 process, their differences are a little bit like white noise. Of course, this is a 2-year difference. We're going to try a bunch of different ways of measuring this, but this will kind of be one of our preferred measures is this 2-year delta. So this is the variation that we're going to be using, both the temporal variation, which is very important, but also some of the within or across state variation. So our kind of primary estimating equation throughout a lot of the paper is going to be this linear regression model. We'll look at an outcome for individual I, who's part of cohort C, who's observed in state S, and is observed in survey year T. And they're going to be assigned a state cohort-specific treatment based on the gas price series that I was showing you. And then we'll have some fixed effects and controls. So the fixed effects here are going to be age-specific fixed effects. So a fixed effect for age 25, a fixed effect for age 26, et cetera, to pretty flexibly control for life cycle trends. For a long time, we just had quadratics in age, but we have the power to include age-specific fixed effects, so why not? We'll also be including these state by year of survey fixed effects to control for contemporaneous conditions. You might be, in particular, be concerned that you observe someone in Alabama, they had a low gas price or gas price shock during their early formative years, and they still face low gas prices. And so we want to make sure that that's not what's driving this. So we'll include these state by year of survey fixed effects to basically control for contemporaneous gas prices or any other things that might affect contemporaneous driving conditions. The controls, we're going to have two flavors of controls. I'm going to call them good and bad controls. The good controls are going to be things that are exogenous at the time of treatment. That is when people are 15 or 16 or 17. So things like sex or race. We're going to, in some specifications, include bad controls or colliders. These are things that could actually be influenced by treatment. And so, reading Angerst and Pischke, we wouldn't want to include them as controls. We think of these as potential mechanisms or mediators. And so we're going to include them in some cases, and we'll see that they actually won't matter very much. So identification in this setting is going to require that there are no latent differences between cohorts that are correlated with outcomes. An example of something you might be concerned about, right, is that gas price increases could cause recessions, and graduating into a recession or these sort of adverse market conditions could have kind of independent effects on wealth and income later in life. And we know that wealthier people tend to drive more and own more cars. So we are concerned about that. There's not the sort of like straightforward econometric solution of including cohort specific fixed effects, which is, a first instinct for a lot of us, is not going to be super tenable here because gas prices are so temporally dominated by temporal variation. So basically the cohort fixed effect will absorb a lot of that. So what can we do? One thing we can do is include quadratic birth year trends. So these will control for basically up to some curvature, secular trends in driving behavior. That could be due to like differences in preferences or gradual adoption of environmental policy, which makes vehicles more expensive or something like that. I think what we can do that's a little bit better is add an additional source of variation, which is where we basically define people's formative window to vary by state based on when they begin to drive. And so this is where we collected this additional driving license data. Just a quick note about the quality of this data. So we basically went back to FHWA manuals to get tables of these ages, and there's not perfect coverage. We basically have observations every other or every third year. And the way that we kind of turn this into an actionable panel is to assume that a state didn't change their minimum driving age if we see them reporting the same age in multiple, consecutive copies of the tables that we have. If we do see them change, then we dig in a little bit more and try to find the exact year in which the change occurred. And so basically then we're going to have these prices, which vary by cohort across state, but are also depending on the minimum driving age for that cohort in that state. And so that's why maybe this notation is a little bit convoluted, but I convinced myself it was the right way to do it. So that's how we're going to merge in the levels, and then we're going to have kind of a similar shock exposure to what we wrote before. So this is going to be the kind of main results, or the meat of the paper. And what we see, to walk you through the table a little bit, is that a doubling of gas prices between the age of 15 and 17. So basically experiencing this shock between the ages of 15 and 17 in terms of your gas prices, real gas prices, reduces the probability that you drive later in life by about 0.4 percentage points. As we kind of move left to right, let me show you what these different columns are. This is the 0.4 percentage points, or 0.38 percentage points, is for the sample of people who are in their state of birth, who still reside or currently reside in their state of birth. And so we call that our like stayer sample. The kind of permutations that we do, we also will include everybody, but we'll merge them to the gas prices in their state of birth. So if that's basically like assuming regardless of where we see we assume that you were exposed to gas prices in your state of birth. The other kind of exercise thing that we can do, or permutation, is to include everybody and merge you to the gas prices in the state that we currently see you, in your state of residence. And the numbers change a little bit, but are significant and negative across the specifications for this 2-year delta specification. So this is between ages in 15 and 17 on the extensive margin. When we look at the definition by minimum driver license age, we actually get a bit more negative and consistent results across all of these specifications. And so if in the back of your head you're thinking about measurement error, maybe this model has a little bit less measurement error. Kind of surprisingly, there isn't an effect of levels that we see persistently across specifications. Although some of the specifications are significant, we kind of think of this as probably our least well-measured specification. And so in our best measured specification, in column 1, we don't really see an effect of price levels. When we add some controls, perhaps there's a slightly negative effect under one way of measuring this. Regardless, it seems that these price shocks matter more than any changes in price levels. So that was all extensive margin effect. Let's talk about the intensive margin effect, which are in these right 2 columns a little bit. So in the NHTS data, we don't know anything about nativity. We only know where you currently reside. So we're always going to be just looking at the set of people based on where they are and merging them back to their, assuming that where they are dictates the vector of lived gas prices that they face. And we see here, in magnitude's a bit larger of a number. This is a 6 to 8% decrease in vehicle miles traveled. So that's roughly 900 to 1,100 miles per year less that people are driving. Here we actually kind of have a little bit smaller magnitude results when we define by minimum driver license age. We're surprised that price shocks, not levels, matter, but this seems to be robust across our different ways of measuring it. And we tried to do a dig into the literature to see what people might have to say about why this is the case. And the only really real reference that we saw was this Haushofer and Fair paper, which pointed to kind of income effects and dynamic changes in discounting. That could be what's going on here. It could just be a general aversion to something that is a really volatile series. I did want to say that this extensive margin effect is, it's 0.4 percentage points. And given that 85% of people drive to work, that might not seem like a whole lot. But remember in the first slide, that was a very constant share. And so I think the fact that we see any effect here is surprising and exciting. And then finally, this isn't just a fancy way of restating what we saw from the picture. These results are robust to, although less precise, dropping out the 1970s oil crises. Any questions on this? Okay, so we'll look at a couple of related outcomes. This is going to be the transit usage and vehicle availability results. And so you'll see that the transit use results are a little bit smaller. This suggests kind of something like maybe a 2/3 substitution to using transit. In the vehicle availability, it depends a lot more on the specification. And so these columns 3 and 4 are looking just at employed people to try to do a little bit more of an apples to apples comparison. Columns 5 and 6 include everybody. We see significant results when we include everybody. We're not totally sure what to make about this. It seems like there might be people who are hit with these shocks drive less, and they might be slightly less likely to have a vehicle in their house. We don't really observe in the census data whether or not you have a vehicle, any particular person has a vehicle. But yeah, these are what these results are. And because this is an environmental crowd, I know that the kind of exciting results are people changing what they're driving. So to this, we're going to just use the NHTS data. We don't see an effect on the gallons per mile that people are driving. So we don't really see a pure efficiency effect. But we do see, some evidence of an effect on whether or not people are driving what I'm calling a big vehicle. So a truck, an SUV, or something like that. And this is kind of, I don't know, this is a largish effect of about 2 to 3 percentage points off of a mean of about 45 percentage points. So there might be some evidence that people are, have a different heuristic about the type of vehicle that they should drive, but it doesn't seem to exactly translate into efficiency terms, and which we were kind of surprised about because these are pretty precise zeros. Okay, so we've seen these results. We want to make sure that it's not just kind of something general about there being these expensive gas prices or gas price volatility during teenage years. We want to tie this more directly to when people start driving. And so what we're going to do is basically include a model with many shocks together. And this will be basically a horse race between the shocks that you experienced at different ages. And what we see when we do that across these basically 4 different specifications, 2 on the extensive margin, 2 on the intensive margin, is that the effects are concentrated in this window between 15 and 17 or 15 and 18. So gas price shocks basically before 15 have 0 effect. And then there's a strong effect between 15 and 16, a little bit of a weaker effect between 16 and 17, and then we kind of fade back in significance. Let me just put up the red box to highlight the results. And so this is a pretty precise and consistent pattern in the extensive margin data. So this is, again, the census data, which is a much larger sample and more precise. In the NHTS data, where we're measuring the intensive margin, we see a similar pattern, but things are a little bit noisier. So, this is still kind of a large number here too. I'll show you some pictures where in a few slides where I show a longer series. But it still seems pretty convincing that it is this 15 to 18 or 15 to 17 window where people are encountering these gas prices that determines this aspect of, or this variation in later life driving behavior.
Chris, is this true? Is that sort of this 14-15 effect true if you just look at the groups of people who saw the price shocks? Does that make sense?
What do you mean by saw the price shocks?
So the people, if you looked at the cohort of people who are going to see a price shock, but the people who were like 14 when that happened, right? Versus just everyone who was 14 doesn't respond to shocks in general. Maybe I'm not asking it clearly.
Well, so this is, this specification is we have everybody. We're basically including everybody in the census. And so we have people who experienced the kind of height of these 1974 and 1979 gas price shocks at 15, and we're implicitly comparing them to kind of the people who experienced these at age 14. Is that your question?
Yeah, that's generally, but this, okay, yeah.
And so in these columns, we've just kind of put a restricted vector of their experiences, all of them as right-hand side variables, and see what comes out significant. And so, this is, you can imagine somebody who's age 35, they experienced a shock. Maybe they experienced the big gas price shock of 79 between the ages of 14 and 15, doesn't affect their driving behavior. But if they experienced it the next year in their age, they do see a change in behavior.
Okay, got it.
Yeah, so we view this as like pretty convincing evidence that this is about driving, about first driving. Obviously we don't know for everybody. The census doesn't ask people, hey, what year did you get a driving license? We would love it if they did for this project, but when people should start driving, this is when we see the effect. And when we do this sort of the merge by minimum driver license age, we see similar effects, a little bit more precise effects. So, to me, this hones in on driving as an explanation. Now, you know, one of the things we want to think about is, okay, what is this kind of, it does look like there's a little bit of a slope coming off of these experiences, and we want to think about that a little bit more. And so we're going to turn to this cumulative exposure function, which will provide us a way to compare basically the effects of early shocks, early life shocks, with more recent shocks. And so what we'll do is adopt the machinery of the Molmindier and Nagel paper, QJE paper. We'll adopt their parametric cumulative exposure function. So if you don't know that paper, it is called Depression Babies. And it's not really about depressions or babies, but they generally find that people who have experienced periods of high stock price volatility or high volatility in financial returns hold more risk-averse portfolios. And so they developed this sort of cumulative exposure function to basically provide a simple way to collapse a lifetime of experience into a single index. And so this is, you know, kind of, we'll use it in the same way. What the function does is provide weights on a vector of experience, and the weights will determine whether or not the past matters kind of monotonically more or less than present results. And so we'll adapt and compare to kind of the results that we were putting up a minute ago. So what is this function? We're going to use it in kind of a linear regression specification like we did before. And this is the specification that they came up with. And so you can see omega here is going to be the kind of key weighting parameter. And it can be any number on the real line. Whether it's positive or negative determines whether early experiences matter more or less. And so when it's here, I've drawn a positive effect. And when omega is positive, more recent experiences closer to today matter more. And when omega is negative, these more distant experiences matter more. So the way that they implemented this equation is to basically just include people's experiences over the whole lifetime of their whole lifetime of experience. Here, given the results on the prior page with these placebo tests, we're not going to let this function turn on until age basically 15. Yeah, and so one little note, we're going to fit this via nonlinear least squares. It was a little bit of a bear to figure out how to implement, because this vector is actually different for everybody depending on how old you are. You know, if you're 30, you include 15 years of prior experience. If you're 40, you include 25 years of prior experience. That's also going to influence how we interpret the results a little bit. You'll see that in a minute. Yeah, so real quick, any questions about this, this kind of functional form before we move on? It is a little bit strong in that it requires weak monotonicity and collapses everything into a single parameter. So the estimates of the numbers we get are shown here. We find, as before, these sort of negative effects. I'll interpret the size in a second, of the shocks. And we find negative values of these of the shape parameter. And so that means, right, early experiences matter substantially more, significantly more than more recent experiences. And so to help us translate between our prior results and this sort of like transformation of what experiences are, here is the derivative of the outcome variable with respect to treatment. This is what we were estimating before in the kind of main results pictures that I showed you here. Here, we actually have to kind of take a nonlinear, take this nonlinear function. It's going to be this beta times a particular weight value that will depend on the age that someone is. And so to interpret graphically, I think is the most useful way to go about it. In this blue line, we have basically the effect of a shock at different ages as time goes on for somebody who is 39 years old. And then, so that's in the blue line. In the gray line with dots, we see the effects that I estimated in the placebo test a few slides ago. And this is just an extended series where we see kind of longer effects. And you see, as before, we see these significant and negative effects in this formative window. This is going to be the 15 to 16 delta, the 16 to 17 delta, etc. And you see that our magnitudes aren't that far off. But what's nice about the cumulative exposure result is that we can compare kind of a recent shock to an early shock. And this is where we get this result that a shock between the ages of 15 and 16 is 25.3 times more important than a shock experienced last year. And so one of the things that's nice, though, about doing these kind of horse race or heterogeneous effects model that we did in gray is that we can find a formative window. In the Malmendian-Nagel framework, either your whole vector of experience is significant or it's not. And so, yeah, that's the extensive margin. We do a similar exercise with the intensive margin. So log vehicle miles traveled, log VMT, right? And so we see, again, a negative shock and this negative weighting parameter or shape parameter, but the shape parameter is much closer to 0. This means that the kind of exposure gradient or the effect gradient is going to be a bit flatter. And so to kind of do the same comparison that we did before, for a 39-year-old, a shock between the ages of 15 and 16 is only 2.7 times more important than a shock last year. Again, we kind of see evidence of this narrow formative window, though. Now, I want to, any questions about that? This is kind of an unusual, it seems like an almost ad hoc functional form that we did with this exercise, but it's relatively standard, I think, in this behavioral finance literature. But it took me a little while to get my head around. Okay. So I think, you know, at least for us, I feel like we were pretty convinced at this point that we have clearly established that there's some sort of a link between these formative experiences of gas price shocks and later life driving. You know, we want to know how to interpret that link. And so we ask, what is this effect capturing? One foremost thing that we still might be concerned about is this effect of scarring or graduating into a recession. And so you know, there are several papers that kind of document these effects in several different areas of economic life, in terms of wages or consumer sentiment or even educational attainment. People who graduate into recessions have a more difficult time with any of these measures. And we'll find that this explains at most kind of a small portion of our effect. The other thing that we're really concerned about is the point that Eric raised earlier, which is, you know, there might be sort of path dependence due to reduced skill acquisition. It's much easier and less costly to learn how to drive when you're at home with your parents. And so it could be the case, right, that if this pushed you out of learning to drive during that window, you maybe never were able to, you know, to learn how to drive later in life because it became more costly. And then we'll also talk about what kind of effect this is after we do what we can to show that these two channels don't seem to be what's going on. So we'll offer kind of 3 pieces of evidence that suggest that graduating into a recession or scarring do not explain the effects that we see. So basically our question here is, are these results just due to an indirect effect of unlucky timing into adulthood? And so the first kind of piece of evidence is that if you think back to the results that we showed, when we included controls for contemporaneous income, that barely changes the coefficients. So that's the sort of, we're using a bad control to show that that's not really modulating our results at all. Secondly, you know, really it was the 1970s gas price movements that are most associated with recessions. There is some, you know, dynamic effects of other gas price movements, but those are really the gas or oil driven recessions. And when we drop those, we don't see the coefficients change very much, although they do become less precise. The final thing that we're going to do is we're going to turn to mediation analysis. And what we'll do is ask if a mediator, which we'll call M, explains our effect. And we're going to do this with 2 different flavors. We're going to use a state-specific unemployment rate that people experience at age 18. And we'll also do a similar exercise with contemporaneous income. And so what does this mediation model look like? We're basically going to be jointly modeling the effect of both treatment or the gas price shock and the mediator on the outcome of interest driving. So that's this kind of top equation here, which is like what we had before, including this quote unquote bad control. But then we're also going to be having a second simultaneous equation, or seemingly unrelated equation, which will measure the effect of gas price shocks of this treatment on the mediator. So you see M is appearing here and has a 0 in the second equation because it's also the outcome of this second equation. So basically you can kind of think of the effect of a gas price shock in this model as being driven through two channels. There's the direct effect, which will be this theta y, which is what we were measuring before. And there's also going to be an indirect channel, which will be this, the convolution of theta m and gamma. So gamma times theta m will give us the indirect effect. So the way I wrote this, I left out the fixed effects just for notational ease. Each variable can have its own vector of fixed effects. And the way that we're going to interpret this is basically providing data consistent bounds on this sort of alternative scarring story. So I'm going to put up a busy table. The actual coefficient estimates are up here. I think it's better to focus on the direct, indirect effects, and total effects here. And you see that across these specifications, you know, at most this indirect effect, when we measure the mediator as contemporaneous wage income, is about, you know, 0.08 or 0.1 percentage points, which is about a quarter of the effect. So we're not saying, you know, that these sort of scarring or graduating into a recession stories don't matter at all, but they seem to be less important than this other gas price, direct gas price shock channel that we're picking up. You do see, especially with these kind of the income or wage measures, that things do go in the way that we expect them to. So this is basically the you know, semi-elasticity of driving with respect to household income, to wage income, and to personal income, and that's, you know, roughly about 2%. So, which kind of accords with the literature. All right, so kind of a different exercise. I learned how to do mediation analysis for this project, which was a fun and exciting thing for me. You know, there are some things to nitpick about identification in these models. And so we don't want to totally hang our hats on these numbers, but we think that this kind of says that, you know, these scarring effects don't have a huge effect explaining what goes on. If anyone has any questions, let me know, but I'll turn now to this point that Eric brought up. Hey, yeah, Chris?
Yeah, so I was trying to think earlier about nonlinear effects, and maybe you just answered my question by running that last set of regressions using T. So was T just the two 1970 shocks, if I understood it right?
That was everything. T was all shocks in that.
Oh, it was all shocks. Okay, then maybe my question is, you have a lot of time periods where I think the price change in percentage terms is pretty small and maybe close to 0. And yet you're trying to explain a lot of variation. I'm just wondering if those years where nothing's happening is dragging down your average effect, and just something nonlinear like the squared price term or a price change to really reflect the fact that when you were sitting in line for hours to get gas, it resonates with you. I mean, I was only 7 years old, but I remember sitting there for hours in the back seat in a hot car waiting to buy gas. Doesn't do anything probably to the way I drive today, but I could see where it would, given the stories that you're describing, maybe for people who are driving then. But right, a small change probably doesn't do much of anything to a lot of people. And disentangling those either with like dummy variables for big shocks or something that is a nonlinear term that would allow that to come out.
That's yeah, that's a good idea. We should investigate that. We have looked a little bit at asymmetry, but I like this idea. I will point out that even when there's kind of on average no change across states, there still are states that are experiencing more substantial changes. But I don't think that that doesn't really discount your point. I think that this is a really good, a good idea of something we should look at. Yeah, I delivered pizzas when I was 18, and there was a gas price shock, and it was substantial and changed my behavior. Marginal changes didn't really affect what I did. So I'll look into that. Thank you for the suggestion. Okay, so yeah, now to address Eric's question, which is, did fewer people learn how to drive? Learning to drive has these important parental and family inputs. If you have had teenage kids, I'm sorry, I feel bad for what I put my parents through when I was learning to drive. And so, we want to ask if these potentially higher learning costs or additional frictions in skill acquisition might keep people from learning how to drive in the long run. Really thinking that this is the best time to learn to drive is 16 to 18, at least in the US. And we'll offer, again, 3 pieces of evidence that say probably not. And so the first is, it's a little bit hard to map this story to the intensive margin effect that we see. Why would these people drive a bit less than other people? It could be that people who have driven more or started driving earlier are just more comfortable and so drive more. That could be a story. But would feel a little bit second order. We'll also show in a slide that there's no strong evidence that teens reduce take-up of licenses around the 74 and 79 crises. This is going to be not measured super well. And then we'll also ask if changes in de jure minimum driving ages impact later life driving. And so here's the picture of basically a national level time series. These are counts of the number of licenses by age from the FHWA highway statistics books. And so a couple things to note, this is a national series and it's a little bit noisy. We also are having to convert these to the probability of having a license. We're also having to divide by SEER population estimates, which are a bit noisy. And so, depending on precisely which series you look at, and you should kind of pick your favorite shock and then move to the right as you go up, because these are progressively older cumulative counts of likely a probability of having a license. Pick your favorite shock. There isn't just anything that is obvious and pops out. One little thing, for testing at kind of age 18 or 20, we would like to see these numbers in 1983 or 1985. I've never had Reagan so directly affect my research. In 1983 and 85, the FHWA didn't collect this data. They just interpolated it from prior years in order to reduce regulatory burden. So that was kind of a fun little thing I saw while collecting this data. Also, I wanted to say what I really wanted to do was get state driver license data. And I called 3 or 4 big states and asked them if they had these series going back to the 1970s and 80s, and they just laughed. So that was unfruitful. So this is kind of, I think, the best we can do in directly measuring licenses by age early on. So that's why we do this slightly different exercise, which is ask, do changes in minimum driving license age impact later life driving? And if so, this is kind of an interesting policy lever and could point to these skill acquisition frictions as explaining our results. But if not, then then it's unlikely that skill acquisition frictions explain these formative experience effects that we see earlier. And kind of what we're thinking here is that these de jure changes in minimum driving license age are stronger or are more extreme than gas price restrictions themselves, because they essentially forbid people from driving. For example, if the minimum age goes from 16 to 17, it forbids people from driving who are under 17 at threat of suspension of future licenses. And so, that threat is likely a bit more severe than an additional $1 per gallon or 50 cents per gallon at the pump. So this also took a fair amount of data collection work. It's essentially the same data that I have used before to do these kind of differential formative window price merges. Okay. Yeah, so just a little bit of background on what the variation in this series looks like. There are miscellaneous changes in these ages throughout, in these minimum driver licensing ages throughout the 70s and 80s. And then during the 1990s, there started to be widespread adoption of what were called graduated driver licensing laws, which provided like a broad spectrum of changes to the whole driver licensing system. And if you're my age, or if you have kids who have gone through learning to drive recently, you've probably kind of experienced these graduated levels that teens have to go through now. So we'll be kind of utilizing both sources of this variation. And we think of these as being strong measures, and compliance is pretty high. Most people, especially if you don't live in the country, if it's illegal for you to drive, you don't drive. And we don't really see an effect on the extensive margin up top and on the intensive margin in bottom. Things are a little bit noisier than we would like. These are kind of the same order of magnitude of the effects that we see, but nothing is significant except for this marginally significant number, but this is significant in the wrong direction. And so we don't think of this as really supporting the skill acquisition story. Now, this isn't precisely the test that we were doing earlier, where we were looking at changes in gas price, changes in gas prices. This is sort of another policy evaluation. But to me, it is pretty suggestive that the skill acquisition channel isn't what's explaining these results, because if so, then we kind of should see an effect here. A little bit of honesty about the intellectual history of this project. This is actually the first thing that I wanted to do when starting this project, because I was thinking maybe if US driver licensing and driver training were more like Europe, that is delayed until people are 18, that might decrease later life driving. And this kind of suggests that that's not the case. So yeah, there we go. Now I just want to talk through a little bit of behavioral economics and how we interpret our results in kind of context of some leading behavioral economics theories, and then I'll wrap up since we're almost at our 75 minutes. I think we use this cumulative exposure function, and kind of that puts us a little bit in this behavioral finance literature. This literature has focused a lot on recency bias. And recency bias just says that people overweight their recent experience towards kind of their full history of experience when making decisions. And we find basically the opposite, that in this setting, people weight their early experiences more than their recent experiences. We don't totally rule out very short window recency bias. We're looking at kind of year level changes in gas prices. There's this recent working paper by Knittel and Tanaka who shows recency bias in basically kind of 10 to 20 day time window variations. And so we just can't see that at all. So it could be we think that it's likely that both are going on, and we just detect this very early bump in the impact of gasoline price effects. And this is also a little bit different. A lot of you may know Megan Bussey's paper on buying convertibles, or that co-author team, buying convertibles being more probable when it's after a sunny day. This is kind of the opposite result than that. There's also this kind of important literature that's been a little bit, mostly in psychology and a little bit in kind of behavioral economics and institutional economics, thinking about mental plasticity. Or impressionable years, the impressionable years hypothesis, which is that teens during this kind of decade of impressionable years are very receptive to outside influence, and that can have permanent effects on their later life voting behavior or other activities. And because our we think of our results as kind of inconsistent with that, or at least pointing to a more particular version of this theory, because there's basically no effect on 14-year-olds, and then there is an effect, or no effect between 14 and 15, and an effect that is strong between 15 and 16. So to me, that says that it's not really this general impressionability. It seems to be about initial interactions or experiences with an activity. And so that could actually provide kind of a mechanism for what has been interpreted as general impressionability. And the final thing that we talk about a little bit is habit formation. And so habit formation is basically this idea, right, that current demand depends directly on past consumption. We can't totally rule this out. There could be some sort of habit formation effect here. The thing that we have trouble with is that really that says that the levels should matter more than the shocks. And so you could think of, maybe the volatility of gas prices rather than high gas prices really reduced teen driving. And then that led to lower current driving. And we can't really rule that story out, but it's a little bit more of a convoluted story. Yeah, so, I think I'm about at time. And so this is, I'll just wrap up. We find that these formative experiences of gas prices during this narrow window between 15 and 18 are altering later life driving behavior. Graduating into a recession doesn't explain this effect, and nor do differences in skill acquisition. And the result is mostly inconsistent with existing behavioral explanations. So thank you all very much, and I'm happy to hang out and talk about this or anything else really.
Billy's got a question, looks like.
Yeah, hey Chris, this has been a fascinating talk. I've been, thinking through it, like what, if kind of like your original goal, like should we raise driving ages to try to encourage more, less driving or something. I was trying to figure out what is the takeaway here. And I guess, so I have one observation and then one question. So my takeaway is we should make initial driving experiences as unpleasant as possible. And then people will not later in life want to drive as much. So that I guess is my takeaway. But the question I had was, based on Chris's, observation when he was 7, it seems like there was partly the high energy prices, there was partly all the other stuff that went with the high energy prices. And I guess I'm curious, nothing in there totally convinced me you could get away from disentangling that, since your highest energy prices and changes were likely coincident with all the unpleasant 7-hour waits in line. Do you have any thoughts about that? I mean, do we have to make teenagers wait in line when they're driving in order to make them not like driving?
That's a great question. And in fact, we've struggled a little bit with the policy implications of this paper because, if your goal were to reduce driving, you might think, well, maybe what we need to do is have highly variable gas prices, or just maybe what we want is volatility in gas prices. I like the way that you frame this, which is, maybe just some notion of making early driving experiences more difficult might have an effect, and I think that might totally be the case. Of course, we don't want to make the driving experience difficult in a way that reduces safety. So I'm not sure what that would be. I think to your point about disentangling these effects, I think that's a great point. To the extent that higher gas prices always lead to longer waits at the pump, or to sort of like other sort of, search frictions as I drive around and try to find the cheapest gas price place, then I think we are unable to disentangle that. When we drop the 1974 and 79 years from our data, what we're trying to do is basically control for the worst of that, or get rid of the worst of that. To me, it suggests that there's still other stuff going on, but we really can't control in a econometric way for these other items. And so
I might have missed that. So you did a run where you dropped those years and you still found similar results. Was that?
Yeah. I didn't put up that table. But we find similar results. They're a bit less precise, but the point estimates are about the same.
Okay.
Chris, my flight is boarding. I'm gonna use my co-host role here to preempt Seth, who also has a question. And my question is, you indicated a number of mechanisms that are likely not explanations for the importance of these formative experiences, but I've been waiting for some theory as to why it is affecting driving behavior so much later in life. And I don't think I heard it. So I wonder what whether you have good data to prove this theory or not. What is your sort of explanation for what's going on here? It's not that they're driving more fuel efficient vehicles or frictions and getting driver's licenses. It's not these behavioral phenomena. What's going on?
Yeah, so I mean, I tried early on in the life of this paper to present a version where I said that these variations in gas prices changed preferences, and I presented that internally, and the macroeconomists in my department had none of it. So we're kind of trying not to say the P word, but it seems that it influences preferences or something that to us is observationally equivalent to preferences, which could be some, risk aversion with regard to like high variability gas prices or something like that. And these people learn about, this particular risk aversion parameter is informed by this early experience. So that's what we think is going on, is that it's about this kind of volatility informing preferences or something like preferences. But yeah, we kind of went through what we thought were first order likely explanations, and we haven't gotten any traction on them. So that leaves kind of everything else, one of which is preferences, and also includes every other story that, we haven't talked about.
Yeah, thanks for that answer. I think it's interesting then that you don't see much of an effect among like the 14-year-old cohort during these shocks, right? I mean, so you're anxiously anticipating being able to drive, although you're not yourself driving, but observing that kind of volatility just before driving doesn't affect sort of your perception of the risk, I guess. It's interesting, but I appreciate your answer.
That's a really great point. We kind of thought that there should be a little bit of buildup there. I think you don't, so I'm going through wedding planning right now, and I think that you don't really know what the price of something is until you're actually threatened with paying for it. And so,
Right, so if I'm going to jump in, we have a few more questions, and everyone, of course, is welcome to stick around. I just want to, before everyone jumps off, I want to thank everyone who's participated today, and we'll see you in 2 weeks. But of course, we're going to continue with the questions for the next few minutes. Thanks. So Seth, you want to go ahead?
Sure. Yeah. Thanks for that presentation. Super interesting. My question is really a follow-up to Steve's question. So, as I look at the intensive margin, one thought is that, it updates your priors about how risky it is to buy a car, because then the price of operating it could just jump on you someday, right? So do you see is there any way to see if people buy less expensive cars lately? So like if they've experienced this, that's one mechanism I can think of.
That is, that's a great idea. We haven't looked at that. I don't. So we did a lot of work to try to, from the NHTS data, match the cars that people say they have, which sometimes are weird things like a Ford Tacoma, to actual gallon per mile or fuel efficiency measures. I don't know if we can do the same thing with price, but my co-author knows a bit more about vehicle pricing data than I do, so I'll talk to Arthur about that. That would be a really interesting thing to do. I know that we could look at the age of the vehicle, which probably is reflecting a lot of things, but could be price, among other things.
Yeah, I mean, if you had model and age, you could probably get something, maybe noisy.
Yeah.
Great. Andrew?
Awesome. So just, yeah, I want to say thanks, Chris. It's nice seeing this paper come along, and thanks to Eric and the organizers for the seminar. It's nice to join. Yeah, so I just had a question about migration. I know that you sort of think about this in terms of robustness, and your sample is conditioned in a way to try and control for this, but kind of in terms of this mechanism, so why we see this effect, kind of an obvious answer, because we know, as you said at the beginning of your talk, demand features so prominently in what we think is affecting VMT behavior rather than supply is whether, so if you're conditioning your sample on people who stay in their state of where they're born, I would suspect that they're in particular sectors, part of the labor market where if you looked at movers, they're likely in different sectors. And I'm wondering, as I recall, when you use the whole sample, there's not a big impact on your results. But I'm just wondering, like, the most obvious thing to me is like people who are affected for this end up maybe either living in different cities or living in parts of cities where longer driving patterns are less likely. But I just was wondering kind of your thoughts of that in terms of interpreting the final result.
Yeah, so I think that's great. So a couple of numbers first. So 64% of the sample is currently residing in their state of birth. And we're treating them as if they have never left in terms of gas price exposures during teen years. Also, public transit in the US, Andrew, as you know, is kind of the New York versus the rest of the country. To some extent. And so think about, I think the kind of most extreme version of this question is think about the people who left their state as everybody who went to New York and who we see in New York City now. They're probably a pretty selected sample. Yeah, so, this is why we try to probe all of these different results and why we don't do a whole lot of heterogeneity or subset analysis, especially in the main regressions, because people are definitely selecting where they live. In the little bit that we do, we see larger effects for people who are in cities. And so to me and we see almost no effect for people who are not in an urban core, and like a pretty precise zero for people who are in rural settings. And so you could just tell a story about that being the availability of substitutes, but there could very well be sorting that is going on in this dimension too. I would think that for most people, when choosing an MSA or a state to live in, the availability of public transit is not the thing that is determining that. Although I have had a couple of people tell me that they will not live in places where they have to learn to drive because they never learned to drive.
Yeah, I mean, correlated amenities though, right? So public
Sure.
transit in cities with large retail density, and also just location within MSAs even, right? So people choosing shorter commutes in the context of the sort of great urban revival that, all that as well, so yeah.
Yeah, no, and I think that's a great point. What I would like to do, and we looked at this for a little bit and it seemed like too much work, but is go into the RDC or look at another data set that's, that really tells you something about more precisely where people live. That would be great to do. The NHTS does have a density variable, like density of neighborhood, but you don't really, it's a binned variable and you're kind of just like taking it for granted how they measured it. And it's very, very noisy. Yeah, I would like to do that because I think there must be some sort of sorting going on. But I can't say a whole lot other than speculating.
So Paige.
Hey, Chris, thanks for the talk. I just had one thought on the mechanism. So we talked a lot about mental plasticity with teenagers, and I'm wondering if it's also just, if it's teenagers or it's mental plasticity with sort of your first encounter with decision-making on like a certain good. Because, so I don't know if maybe you see the age that people get their license, but it seems like it's most likely going to be teens, but I'm wondering if you could, and you could see if there was a differential effect for teenagers, or if not, then it's kind of maybe a broader story of like, which kind of maybe has parallels to like energy efficiency literature of like mental plasticity within like the first time that you're sort of engaging with a new commodity.
That's so the easy answer is that, to the best of my knowledge, that data doesn't exist in any sort of like historical sense. You could go to like a state DMV now and get a recent, kind of a recent history of driver licenses. But I think that the point that you bring up is really good. You know, what if everything was kind of the same, but people learned how to drive at 22? Would there be something different, you know, because they're learning to drive at 22? I don't know. I think that's a great question. In the US context in particular now, if somebody is 22 and is like learning how to drive, it's because they need to know how to drive. And I feel like they would be less influenced by the price of gasoline on that margin, but in kind of a different world, I'm not sure.
All right, I guess Tegan's next.
Hi, I'm Tegan, and my question isn't very complex, but I'm listening to you from Montana, where we have like zero public transportation. So my question is kind of, if you, like, you said that this is all driven by the urban core and that these are significant effects for the urban core. So would you see a larger effect if you just limited to what is the effect of a price shock on individuals living in urban cities, ignoring all people in micropolitans and rural communities? Do you think you would see a larger effect in maybe that would be a better way to understand a policy mechanism out of this?
That's a great point. No, and thank you for that. So yeah, when we look just in cities, we see a larger effect. So right, the kind of baseline effect is 0.4 percentage points. Just within urban cores, we see about a 1.9 percentage point effect. That is, you know, as Andrew pointed out, conditional on selecting to live in an urban core. So that's why we are a little bit hesitant with those numbers. But yeah, they're in rural places, there's almost no effect on the extensive margin. I think what we could do, and I am having trouble remembering if the NHTS will allow us to do this, is where there might be, we could really exploit the difference between the intensive and extensive margin. Right, in rural settings, if you need to drive to work, if you need to get to work, you're gonna drive. But people might they might have different driving behavior in terms of, you know, this intensive margin. They might choose to live closer to work, or they might take fewer car-based other trips. And so that's something we could look at. Thank you.
All right, Billy.
Just double dip here since nobody else is in line. You know, I was wondering when you were talking a minute ago about, you know, proxies for availability of amenities or opportunities, maybe the walkability score that's available now would be something that would give you some measure. I know that was something I looked at when I moved to Durham. And the other thing I was thinking about, which really isn't your paper, but kind of, I guess, is what Knittel was looking at, is just how much ride sharing and kind of, you know, recent changes may influence the relationship you're looking at.
Yeah, those are both great suggestions. I think looking at walkability would be cool. I'll try to check that out. In terms of ride sharing, I do think it would be really fascinating to know, you know, basically to kind of do this again in 10 years, where you see people who have basically experienced their kind of early life mobility in a world in which you can have rideshare. And so like the worry about getting stranded somewhere if you don't have a car is like much less important. I think that would be really cool to do. Yeah.
Yeah, I mean, I was just having conversations with some people, and you know, when I turned 15, like I had to get my license, you know, because I wanted to go places. Now people are like, I don't need my license to go places, you know, why worry about it? So
Yeah, well, and I mean, I think too, that is maybe, something which is going on in the background. And so we have trouble really working with or dealing with, but the US has been consistently since the kind of, like the 80s was kind of the low point in public transit provision in the US. And so since then, there have been better, more increased bus and other transit offerings in the US. And, in the last, eight or so years, Uber and Lyft and ride sharing. And I mean, I think that there's both the perception and the reality of like better supply of alternatives.
All right, open it up. Anyone who has any other questions? Otherwise, I think we're done.
Well, this has been really great feedback. I want to think through these the kind of these great questions that we've gotten a little bit more. So I might follow up with some of you. But this is very helpful and I appreciate it.
All right. Well, thanks so much, everyone. We'll see you in a couple weeks.
thanks, Eric. Thanks, Chris.
Thanks, everybody. Cheers.